Hello, my name's Adrian and this is the demo of my Bicycle Safety Kit Embedded Device project, which is a GPS tracker that helps you find the safest routes on the road. This project uses an embedded device to track a bicycle's location with GPS and senses proximity to other obstacles while the bike is active on the road. When it senses an object closer than 2 meters, it publishes an event which captures the distance as well as the current latitude and longitude. Another device in the system runs a home dashboard which fetches that data and creates a location heat map displaying the events. This visualization helps us to compare route safety and make decisions about which roads to take. On the bicycle side, for the hardware, we're going to need a particle electron, the Adafruit Asset Tracker Kit, which includes the accelerometer and GPS, 2 ultrasonic sensors, a LiPo battery, a 5-volt voltage regulator, various LEDs, resistors and wires, and the software for that part of the system. We need a custom C++ program to run the Electron firmware, the Asset Tracker library from Adafruit, Particle Cloud service and their 3G mobile data service, the ThingSpeak service, and If This Then That, which sends out a battery warning. On the dashboard side, we have a Raspberry Pi with a monitor and internet connection. Now, the software that we're running on the Raspberry Pi is a JavaScript and HTML page, which fetches data from the ThingSpeak and Google Maps API, and that's also running an Apache web server. Okay, here is a demo of my project. I now have the kit all mounted to the bike and it's free of any external power supplies. I've got the battery, it's all running off the LiPo battery inside there. Thanks to this 5-volt pull-up voltage regulator that I ordered, which worked really nicely. The green light here indicates that we have a GPS signal, which is great, and I've got this all mounted quite securely on there now. It's semi-weatherproof, at least the expensive parts are. It's proved to be a little bit too difficult to completely weatherproof this thing on a limited budget, but if I get desperate and I'm out riding, I'm just going to cover it up with this little plastic container. So we have our distance sensors all mounted on the side. They're all ready to go. The system is not running at the moment because I've got the accelerometer set up to detect bumps, which means that we're not going to get any false positives when we park the bike in the garage, for example. We don't want to be, say we park up against a wall or something, we don't want to be sending a whole bunch of false positives. So I have a timeout set with the accelerometer. When it detects a bump, it will activate the system. So if we give this a bit of a shake here, the blue light will come on. There we go. And when the blue light is on, it means the system is active. I'll just bump that again, and I'll put my hand there. We have a red light which indicates a proximity event, and I'll just give it another shake just to recreate the effect of actually riding the bike. Look, I've got my hand in front of this right here, and there we have that red LED indicating another proximity event. I'm now taking note of the battery power that remains, and if the power goes below 25%, we get a particle publish event, and that then gets sent to If This Then That to send me an email just to give me a heads up. Also, every 4 hours it will report the battery status to another ThingSpeak event, so we have data that we can pull down to our dashboard to make the battery level a bit more visible. And here we have a view of the system, which I've mounted using screws onto a wooden frame, and put some screws right through, which I then mount onto the frame of the bicycle with a couple of mounts. so that I can remove it as I please. Okay, so here is my Raspberry Pi, which is running the home dashboard. And as you can see here, I have a map that's just refreshing now. I have a map which is serving as a heat map for all the data points that I've collected. At the top of the screen I have the battery status of the Electron, which is now sitting at under 80%, which is fine, and the date that it was updated. And I made the map grayscale so that you can see the heat map a little bit more clearly with the colours. Red indicates closer than a metre, orange indicates closer than 1.5 metres, and yellow indicates closer than 2 metres. And so from this data it's quite useful. You can see that there are some routes around my neighbourhood that are safer than others, particularly down here. This is a bad stretch of road which doesn't really provide very good bike lanes or anything. But you can see there's some other alternate routes. Oh, it's refreshing. Some alternate routes here that we could take. Say, for example, if we wanted to come down here, I would not take the main road here. It's probably best off if I go down that road because we can see that would be a little bit safer. And also we have the blue dot up here which indicates the last known location of the bike, which is a nice safety feature. And also I have this running an Apache server, so that means that I can access this from anywhere. I've got the same data available on my phone with the battery status and all the same data, so we can get out and about, which is probably a little bit more useful than viewing this on the Raspberry Pi. So we can use this on our phone as well, which is really handy. So how did I go in this project? It's time to evaluate and have a bit of a think about whether I built it right. Overall, I was very happy with how the project turned out, although in a prototype there's always room for improvement. I really wanted this system to excel in a few key areas: accuracy and portability, so I focused on those two. Now, what went well? I felt I did a good job of considering potential fault scenarios, for example, a false positive guard, which means waiting for 3 positives before treating it as a true positive, deactivating the sensors when it's motionless via the accelerometer, don't attempt to publish particle events if there's no 3G connection, don't attempt to publish events more than once per second, this is due to the particle service rate limit, and guard against readings of 0 triggering a proximity alert. I also designed with efficiency in mind, for example exiting out of the loop if the device is motionless and not taking readings from the ultrasonic sensor when we didn't have a satellite fix. Real-time response also became an important factor in the project because there are natural temporal restraints associated with fast-travelling cars. My early tests revealed that using a sleep delay simply didn't cut it when cars were whizzing past, so I had to remove all those restraints and continually take sensor readings, otherwise the system just couldn't cope. Reliability was also important. This device is designed to be a set and forget kind of thing, so I designed the software to be run continuously for weeks without interruption. I also added battery status updates every 4 hours and a low battery alarm to give you a warning when it needs charging. And what didn't go so well? Well, the cost of this project blew out when I found that the Wi-Fi and cell tower triangulation was going to be way too inaccurate for me. The GPS and accelerometer components were expensive, so if I had my time again, I'd try to assemble my own and try to find some cheaper components. The weatherproofing turned out okay, but still leaves a little bit to be desired. The weatherproof case for the GPS was excellent, but the rest of the system is basically exposed. So with a little bit more time and budget, I would order a PCB based on my design and 3D print a case perhaps to improve that aspect. The other thing was that the fault tolerance is still not perfect. Even though the device is deactivated when it's motionless, it's still possible to wheel a bike around in a garage and trigger a bunch of proximity alerts when you're parking it. So that's another aspect that could be improved. In summary, I had a really enjoyable time building this project and piecing all of it together, and I look forward to building my next one. Thank you for listening.